Hi, and welcome to section 3.3, where we're going to be talking about two of our basic rules of probability. We've discussed these a little bit, but we're going to go over them one more time. Our first rule is called the multiplication rule. And if A and B are two events defined on a sample space, then we have these rules. And we've sort of talked about these again, but we're going to go over them one more time. If A and B are dependent, so that if A occurs or B occurs, it changes the probability of the other one, then we know that the probability of A and B, oops, that was not a drawing. Let's see. A and B, that's what that says. A and B is the probability of A times the probability of B given that A occurred. All right. And we also can write this, if we multiply and rearrange this formula a little bit, another version of the same formula is that the probability of B given A is the probability of A and B over the probability of A. All right. So those are the same formula, just rearranged. And if A and B are independent, this formula is even easier because that means that they don't have an effect on either one. So that if that is true, then the probability of B given A is just the probability of B because A's occurrence doesn't have any effect on the probability of B. So if they're independent, this formula of the probability of A and B, both of them occurring, is just the probability of A times the probability of B. So we have two different formulas. They're based on the same thing. So make sure you put these down and draw a box. And remember, this is A and B. That little symbol in there looks like an N a little bit, and I remember it says A and B. Let's do an example of how this works. All right, let's have a bag of marbles. We have 2 red, 4 green, 3 blue, 5 yellow. In this first experiment that we're going to do, we're going to pull a marble from the bag. We're going to look at the color. We're going to put it back in the bag, and then we're going to draw another marble. Okay? Let's let A be that the first marble is blue, and B that the second marble is yellow. All right, the first thing we need to ask ourselves is are A and B independent? Are they independent? Pause the video right now and see if you think they're independent or dependent. All right, did you come up that they were independent? We put the marble back in the bag. Okay, we put the marble back in the bag. So no matter what we get for the first draw, we put it back in. We're exactly at the same spot for the second draw. So they are independent. I wonder if I put, yes, A and B are independent. So thinking about that, we know that we can find some probabilities a little bit easier. So let's go ahead and find the probability of A. Ignoring that B occurs, we just want to know that the probability that the first marble is blue. Well, there's 3 blue marbles. How many are there total? 6, 9, 14. So I think the answer is going to be 3 out of 14. 3 out of 14, 3 blue, and there was 14 total marbles. All right, what's the probability of B given A? Pause the video and see if you can find the probability of B that the second marble was yellow, given that the first marble was blue. All right, did you remember that they're independent and it doesn't matter about A? So the probability of B given A is just the probability of B because of the independence, right? Doesn't matter what A was. So it's just the probability of B. Well, what's the probability that the second marble is yellow? Well, there's 5 yellow marbles out of 14 total marbles. So that's 5 chances in 14. All right, our last one here. What's the probability of A and B? So the probability the first marble is blue and the second marble is yellow. And remember, they're independent. Pause the video, see if you can calculate that. All right, remember, if they're independent, I'm underlining one more time, then the probability of A and B is just the probability of A times the probability of B. So that's 3 and 14. We figured that one already. And 5 and 14, which is the probability of B. And we multiply those by multiplying our numerators. 3 times 5 is 15. 14 times 14 is 196. So that's my probability of A and B. So that was an example of independent events that don't depend on each other. When A occurs, it doesn't change the probability of B and vice versa. All right, let's do this example one more time. We have the same bag of marbles. This should say in the second experiment. I'm just going to cross that out. How do you like that? In the second experiment. We're going to pull a marble from the bag. We're going to look at the color. We're going to put it in our pocket, not back in the bag, and we're going to draw out another marble. All right, so the same events. A is that the first marble is blue, and B is that the second marble is yellow. I'm not going to even let you think on this one. I'm sure you guys have already noticed that, of course, the A and B are not independent because we have less marbles in the bag. One way you can look at it straight off the bat is when you do the second draw, you started with 14 marbles. And now when you put one in your pocket, you're only going to have 13 marbles left. All right. So let's see if we can find the probabilities here. Well, the probability of A hasn't changed. Nothing happens. We haven't even done B yet. So it's still 3 chances in 14. What's the probability of B given that A occurred? So if A occurred, that means that we drew the first marble was blue. So now we have a different scenario in our bag, right? This time, after the first draw, we still have 2 red. We still have 4 green. We don't have 3 blue anymore because we drew one out. We have 2 blue ones. And we have 5 yellow for a total of 13. All right? So the probability that B occurs given this new scenario, what is that going to be? Well, it's going to be 5 chances in 13. We still have 5 yellow marbles out of a total of 13 marbles. Did I do yellow last time? For some reason, I feel like I didn't, but moving forward. All right. So we have those two guys figured out. What is the probability of A and B? So what is the probability that A is a blue, first marble is blue, and the second marble is yellow? Well, we're going to use our formula from that very first page that I told you to write down. And the formula says it's the probability of A and B is the probability of A times the probability of B given that A occurred. We have those things nicely computed up here. We know the probability is A is 3 chances in 14. The probability of B is 5 chances in 13, B given A. And so the total probability is the multiplication of those two guys. 3 times 5 is 15. 14 times 13 is 182. All right, so in a lot of ways, these two examples are pretty similar. You really figure out the probability of the first event and then the second event. But the thing is, when you put the marble back in the bag, you've really changed the probability of what's going on in that second part of your product, right? We don't want the probability of B because we didn't draw out of a 14 marble bag. We drew out a 13 marble bag, and we need to adjust that probability for that. All right, next rule. That was the multiplication rule. Now we're going to talk about the addition rule. So if we have A and B defined on a sample space, then the probability of A or B occurring, so one or the other, or both, is the probability of A plus the probability of B minus the probability that they both occurred, A and B. And if A and B are mutually exclusive, that means they both can't happen at the same time. Remember we talked about that last time? Then that probability of A or B is 0, okay? Because they can't both happen. So that means that the probability of A or B occurring is the probability of A plus the probability of B. Again, this is formulas you should write down right now in your notes and draw a big box around them. Excuse me. And remember that this is A or B. It probably wouldn't be a terrible thing to have in your notes right now that remember this equals or and this equals and. Maybe like a little post-it and stick it to your computer or something. Let's do a same example and let's just do a addition rule example, an or example. Same marbles, same bag, same first experiment. We're going to note the color, put it back, and draw another marble. All right, so A is that the first marble is blue, and B is that the second marble is yellow. First question, are A and B mutually exclusive? Can they both happen at the same time? Yeah, no, they're not mutually exclusive. Yeah, they are definitely not mutually exclusive. You can draw a blue and then put it back and draw a yellow. That's completely a feasible thing that can happen. All right, so they are not mutually exclusive. I don't know why my answer is already down there, but let's walk through it anyway. It popped up a little too soon. So the probability of A or B occurring, okay, that's going to be this symbol is the probability of A or B, and we're going to put in our formula that we just learned. It's the probability of A plus the probability of B, but that would be over counting because we could have all those times when A and B both occurred. That's what this last part is. Okay, all the times A occurred, so that would be like blue, blue, or blue, red, or blue, green, etc. The probability that B occurred, this would be like if we had like red, yellow, green, yellow, etc. All those guys. We're going to count all those chances that could happen. All the times the second marble is yellow. But then we need to uncount or not include again all the times that they both occurred. So this is all the probability that you got a blue first and then you got a yellow. Right? So that's why we're subtracting those off, because we already counted those. So the probability of A is 3 chances in 14. The probability of B is 5 chances in 14. And the probability that they both occurred is 15 chances in 196. We calculated this when we did our OR. Remember back in the very first experiment, we did this one. Hang on, back up. Why is it undoing? Well, right here, right? We calculated, right here, 15 and 196. So we are using our previous work. We know how to calculate that. You could calculate it again if it was another problem. So let's forward to that. Too far. All right, so we're going to subtract 15 and 196 that we calculated from before. That's the probability of A and B both occurring. And we can use our calculators or however you want to do your math here. That turns out to be 97 and 196. All right, so that's an example of the addition rule. All right, let's do one more example here. A student goes to the library. Let event B be that the student checks out a book, and event D be that the student checks out a DVD. We're going to tell you right now that the probability of B is 0.4 or 40%. The probability of D is 30% or 0.3. And the probability that they check out a DVD, given that they check out a book, is 0.5 or 50%. I want you to pause the video and try to find the probability of B and D. So that's probability of B and D. And I also want you to find the probability of B or D. Remember, that's or D. And we have some formulas for these. So go ahead and remember those formulas that I told you to write down and give those a try. Pause the video and then we'll go over the answer. All right, are you back? Awesome. Here's my answers, one at a time. So the probability of B and D using our formula, so this is our formula, is the probability of B times the probability of D given B. And luckily, we were given all these values. So we got the probability of B is 0.4. That comes from here. The probability of D given B is 0.5, and that comes from there. 0.4 times 0.5 is 0.2, right? So that's a probability that the person checks out a book and checks out a DVD. The next one is the probability they check out a book or they check out a DVD or they do both, right? That's included in there. So we used our formula for or, the addition formula, and we know that's a probability of B plus the probability of D minus the probability of both things occurring, all right? Which luckily we just computed. So probability of B, again, was 40%. We were given that information. The probability of D was 30%. We were given that information up here. And minus from that the probability of B and D, which we just calculated here. And so that's minus 20. So 0.4 plus 0.3 minus 0.2 is 50%. All right. Well, those are the examples on how to use the material over how to use the multiplication rule and the addition rule.